Hello everyone, hope all are doing fine after a long gap. Again back to carbon chemistry. Today we will see about the chains, branches and the ring structures. Okay. But before going into that, we will see a recap of the structures which we have studied. Okay, we studied the classification of organic compounds as alkanes, alkenes and alkynes. And you all know the general formula of alkane is En2NH2n plus 2, alkene is H2n and alkyne is CnH2n minus 2. And if I am not wrong, we have written the first 10 compounds, that is up to C10 of the family of alkanes, alkenes and alkynes. So today we will see some more structures, how to write the structure of alkanes. Okay, the first 5 structures of alkanes. Okay, just to have a recap of that. So first is methane, meth. Okay, so I am only writing this saturated alkane, methane. Okay. Now, you know meth means only one carbon atom. Okay, now methane, if it is one carbon atom, and if it is a saturated compound, it should contain 4 bonds, isn't it? And that too satisfying the hydrogen, isn't it? So, this is the structural formula. What is it? Structural formula. This is a structure, isn't it? Structure. So, this you can call it as a structural formula. Now, what is it? See, whenever you write a carbon compound, just make sure that this carbon satisfies the 4 valency. Whatever be the compound you are writing, just keep in mind that the carbon must satisfy the 4 valency either by single bond or a double bond or even a triple bond. No matter what the type of bond, but carbon should contain 4 valency. That's all. Okay. So this you can have the name methane, ane, that is saturated alkane. Meth means one carbon atom. It's a saturated compound because it is ane, and so it must contain 4 hydrogen atoms. Okay. Now this is a structure of methane. Now you can condense it. You can have a formula for this. How you write the formula for methane? You write the formula for methane as CH4, isn't it? You can't write every time this structure. It's not possible. So you have a formula. This is called as a condensed formula or simply formula. Okay. Now the second is eth. If the first one carbon atom, it is called as meth. Second is eth, isn't it? Eth. And you are only talking about saturated compound, that is alkane. So it will be ethane, isn't it? 2 carbon atoms, it will be ethane. And what will be the molecular formula? You know what is CnH2n plus 2, isn't it? So CH4, then if C is 2, C2H6, isn't it? You will see that is 2 carbon atom saturated. So it will be C2H6. This is the formula. See, now I will write the condensed formula of this. The formula for ethane is C2H6. Okay, but you will get more information when I write this as a condensed formula, that is CH3. See, this C. I am talking about this C. How many hydrogen atom? 3 hydrogen atom. So I put CH3. Then there is a bond here and making the other carbon atom bond, and it forms like this. So you can write ethane as like this. This is a structural formula, this is a condensed formula, and this is just a formula. For methane, both condensed and formula are same because only one carbon atom. You got it? Okay. Now coming to the third compound, the carbon atom, 3 carbon atom. What will you call? Prop, isn't it? Prop. So prop and ane. Ane means saturated, single bond. So there are 3 carbon atoms, so it will be C3H, how many? 7, isn't it? Cn 3 into 2 6 plus 2 8. Okay, C3H8. Just get into that formula, that's all. So we will have 1, 2, 3. That also you studied last class. How to get that formula. First step is, step number 1, write the carbon atom and join with the double bond. Then satisfy with hydrogen atom. If the valency is not satisfying, give it a double bond or a triple bond, isn't it? So here 1, 2, 3, 3 carbon atom and 8 hydrogen atom. First you will satisfy 1, 2, 3, 4, 5, 6, 7, 8. So it is satisfied. Okay, so it will be like this. Hydrogen atom. You know how to write the electron dot structure also, isn't it? By sharing. So this is the structural formula. What I want to mean is, this is a structural formula. And how can I write the condensed formula of this? See, this is CH3, the first carbon atom, this is second carbon atom, and this is the third carbon atom. So first carbon atom, I will write CH3, listen, CH3. Then a bond between the two carbon atom. Okay, carbon atom. And now how many hydrogen atom are there? 1 and 2. So I can write H2, 2 hydrogen atom. Again a bond, okay. Then the carbon atom. And how many hydrogen? 3 hydrogen. So I can write CH3, CH2, CH3. Got it? So the formula is C3H8. This is the structural formula. You are making elaborating the structure as a whole. This is the condensed formula. Got it? 2 more I will write. The fourth one is, what you call it as 4 carbon atom? Bute, isn't it? Bute. So fourth is bute. So it is butane, butane. If it is an alkene, you can call it as butene. If it is an alkyne, you call it as butane, by-N-E. Okay. Here only we are dealing with single bond. So butane, butane, get that formula, C4H10, isn't it? 2 into 4, 8, 8 plus 2, 10, C4H10. Now, how will you write, how will you get into that structure? How will you write the structure? 4. So, join the carbon atom with single bond, 4 carbon atom, 1, 2, 3 and 4. Then, satisfy with hydrogen atom, and if the hydrogen atom is not enough, then put a single or double or a triple bond. But here there is no way for double or triple because it is a saturated compound. There is only single bond possible. So let us see 1, 2, 3 and 1, 2, 3. First you have to write the terminals, or else it's okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Well, so C4H10. 10 hydrogen atoms will be there. 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it is C4H10. Okay. Now write the condensed formula. You know the formula. You know the structural formula. Now write the condensed formula. Tell me, what is it? This 1, 2, 3, 4. So this is CH3. Am I right? CH3. Connection between the carbon-carbon. How many hydrogen atom? 2. So it is CH2. Isn't it? Again the connection of CC single bond. How many hydrogen atom? 2. That is CH2. Okay. Now this carbon to carbon single bond. Again the terminal carbon atom. How many hydrogen atom? 3. So always remember or make it a point. Whenever you write an organic compound having carbon, please see the valency is satisfied. Make sure. Okay, otherwise the compound will be wrong. Okay, so this is butane. Okay. Now, till propane, it is okay. Because you can't write any other structural formula till propane. That is methane, ethane and propane. But when you see this butane, that is having 4 carbon atoms, you can change this to a different structure. Got it what I said? This is butane, that is 4 carbon atom. For example, I will write the skeleton, carbon skeleton. What is carbon skeleton? Only carbon. I am not going to write the hydrogen. Listen, I am not going to write the hydrogen. I am only going to write the carbon. That is why I call it as a carbon skeleton. Okay. Now, carbon skeleton for butane is 4 carbon atoms. Okay. So, the carbon skeleton is 1, 2, 3 and 4. Can I write one more skeleton with the 4 carbon atom other than this? Just see. whether you could do that? There must be 4 carbon atom altogether, but it must be in another skeleton. Skeleton means not in this form, but in any other form. Not like this, but it should contain 4. So it can be like this also, isn't it? 1, 2, 3 and 4. Correct. Or if somebody says 1, 2, 3 and 4. Same. Both are same. If you put it upside down, it will come same. So no point in that. This and this is same. Okay. Any other way? Any other way? So this is called as carbon skeleton structure. Okay. Only carbon is there. So from butane onwards, propane till propane, if it is 3, you can't write like another skeleton, because anyway, if it is like that, this is same, straight chain, isn't it? And if you put like this, it is also same, 3 carbon atom in a straight chain. Okay, so till propane it is okay, but from butane onwards, you can have more than 1 skeletons. Butane, there is only one more skeleton. Okay, so you can write this 4 carbon at a stretch or in a straight chain. So it is called as a straight chain skeleton, because there is nothing branching. But here, see, here there is a straight chain, but in that straight chain there is one branching. This you call it as branching. You can have it either upside or downside, no problem. Okay, so this is branched. So this you call it as a straight chain compound. Okay, straight chain, and this is called as branched. Okay, so that is why we say branch chain. Straight chain is also called as chain. Okay, chain compound. There is no branching. That is why you call it as chain. Simply chain. Okay, so now coming back. So this is a carbon skeleton. Now we will form the complete molecule. Okay, now what about the complete molecule? C4H10. Now if you put the hydrogen atoms into it to satisfy 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is what we have said earlier. Correct, that you know. But what about this? Can we satisfy the hydrogen 10? Let us see. So 1, 2, 3, 4. So 4 carbon atom is okay. But see, 1, 2, 3. 3 hydrogen atoms. Okay. How much you need? 10. So 3. Now here 1, 2, 3. See, that is why I told you, whenever you are writing carbon compounds, make sure its valency must satisfy 4. So here see 1, 2 and 3. Where is the other valency? So you go for 1H. That is 4. So this first carbon atom 1, 2, 3, 4. Okay. Second carbon atom 1, 2, 3 and 4. Correct. Third carbon atom 1, 2, 3. So hydrogen 4. Okay. So 1, 2, 3, 4, 5, 6, 7. How much you need? 10. So here this carbon atom, there is 1, then 2, 1, 2, 3. So see 1. So total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this compound is also having a formula C4H10, isn't it? Just see. This is also C4H10. Am I right? Because C4 and H10 all together. This is also C4H10. See 1, 2, 3 and 4. But the difference is, one is a straight chain compound or simply a chain compound, and second is a branched compound. There is a branch in this compound. You can have more than one branches in other compounds like hexane, heptane. If the number of carbon atom is increased, you can make more branching. But for butane, you can only have one branch. The others, it won't happen. Till propane, there cannot be any branch. So from butane onwards, you can have both straight chain compounds as well as branched compounds. Understood? Okay. So now you can write the condensed formula of the first one and the condensed formula of the second one. Okay. We will write. In the textbook, it is given as like the skeleton is given as 1, 2, okay, 3 and 4. Same as like this, isn't it? We call this as a straight chain and this as a branch. Okay, or this as a straight chain, this as a branch. Never mind. Okay, that's why I wrote in a straight chain and one branch like this. This also is same as this. Just you make the angle different, that's it. Okay, so 1, 2, 3 and the second carbon atom, there is a branch. See, here also 1, 2, 5, if I number it. 1, 2, 3, in the second carbon atom, there is again a C. Here, 1, 2, 3, second carbon atom, there is again a C. The same thing. Just in the textbook, it is, the angle is different, that's all. If you put that straight, it will be like this. Okay, so this is to study easy, that's what. Don't making into confusion. Okay, so if I write the condensed formula, how can I write the condensed formula of the first one? So this is the first one. See, this side. This is the first one. Tell me. This is CH3. Okay, CH3. This is CH2. Now, CH2 and CH3. See, the first straight chain compound. C4H10. Correct. Now, the second one is CH3. The first C. Then, listen, this is the carbon-carbon, contains only one hydrogen atom, isn't it? One hydrogen atom. Then, it is having a branch and then C, listen. And then this C has got 3 hydrogen atoms. Am I right? Once more. This CH3, 1, 2, 3, that is CH3. Single bond C, that is this C. This C contains only one hydrogen atom, that is this hydrogen atom. But this is branched to another C, that is this C. And that C has got 3 hydrogen atoms, that is CH3. Okay. Now, this C is connected to another carbon atom, which contains 3 carbon atoms. See. So, listen. So, are these two structures same or different? Definitely, this structure is different from this structure. Because this is a straight chain structure. And this is a branch structure, isn't it? But are their formulas are same? The molecular, this is a molecule, right? This is a molecule, you can say. Now the molecular formula is same. This case, it is same, that is C4H10. In this case also C4H10. So, if a compound, for example butane, having same molecular formula, that means C4H10, but having different structures, see, different structures, then they are called as structural isomers. What is it? Structural isomers. Now, how can you define structural isomer? What is structural isomers? Isomers means what? Isomers means same molecular formula, C4H10, but different structures. That is why it is called as structural. Different structures. Same molecular formula but different structures. They are called as structural isomers. So what is the value point? Structural isomers is same molecular formula. Okay. But different structures. So such isomers are called as isomers. Okay. Isomers. And such compounds are called as structural isomers. Got it? So, this is called as structural isomers. Now, if you go for the next compound having carbon atom 5, you call it as pentane. Okay. Can we have the structural isomers of pentane? Can you have it? Or you can do it homework. What do you prefer? Can we do here? Okay, you can do it here. Okay. So, a carbon atom having 5, which is called as pentane. Okay, it is called as pentane. So, it is C5H12. See, C5H12. Now, first we will see the skeletal structures. Okay, we will see the skeletal structure. 5 carbon atoms. So, 1, 2, first structure. Okay, first structure. 1, 2, 3, 4 and 5. Skeleton. Okay. 1, 2, 3, 4, 5. Then second structure can be 1, 2, 3, 4. Correct? 4. And one more C. See? One more C. Okay. Now, somebody is telling me this is also correct. See, 1, 2, 3, 4. And here it can be 5 to the next carbon atom. 5. But listen, if I put this like inverted, like this, ulta, like this. It will become this. Isn't it? Listen, if this is like this, I put this C here. See, this, for example, I will number it. 1, 2, 3, 4. Just for sake of your understanding, this is numbering it. I am folding this carbon atom to this side. So it will be first carbon atom to this side. So this will be 1, this will be 2, okay, this will be 3 and this will be 4. Correct? Now see these two structures. Is it same? Yes. So this cannot be written. Understood? Okay, so these two structures are same. Why? Because you are again getting back into this, you will get this. So you cannot take that as a structural isomer. Same, replica. Okay, so that cannot be. Then how it can be? So there is two structures. Then the third structure, just see, just think of it. 1, 2, 3, 4, okay, 5th one. 1, 2, 3, 4, here 5th one is same as like this, so you can't write that. Then any other? Any other? Can we write like this? 1, 2, 3, 4, 5. See? 1, 2, 3, 4 and 5. Yes, you can write. Isn't it? Got it? Okay. Again, you cannot write that because already 3 and 4, 5. Okay. So these are the carbon skeletons of pentane. Okay. Now we will add the hydrogen atom. Correct. So it should be H12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Correct. Isn't it? So what is the condensed formula? CH3, CH2, 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 CH3. Correct. This is the condensed formula. Or the first structural isomer is this. You call it as pentane. Okay. Next is how? This is 1, 2, 3. Okay. Listen. 1, 2, 3. 1, 2. See? This carbon atom 1, 2, 3, 4. Satisfied. This carbon atom 1, 2, 3. Again 4. Sorry. Here it is C. No? Third we will draw later. See. Okay. So this is hydrogen. Okay. Now for here, this carbon atom 1, 2 and 3. Okay, this carbon atom 1, 2, 3 and 4, correct? And for this carbon atom 1, 2, 3, 4. See, this is the second structure. So you can write as CH3, CH2, 2 carbon atom, so hydrogen atom. Again CH, branching CH3, then straight CH3. So this is the second structural isomer of pentane. Got it? Okay. Now the third is what you have written like this. 1, 2, 3, 4 and 5. Now draw the hydrogen. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So it will be 3 plus 3, 6, 6 plus 3, 9, 9 plus 3, 12. C5, H12. So how will be the third structure? Third structure will be CH3, 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 CH3. See? It will be C5, 1, 2, 3, 4, 5, H12. Here also C5, H12. Here also C5, H12. So, the point is, the compounds which have same molecular formula but can have different structures. See, this is a chain, this is again branch, this is again branch. So, such type of compounds are called as structural isomers. Got it? Structural isomers. Okay. So, in board exam, the questions are asked, write the structural isomers of pentane. Okay. They won't ask you for hexane or heptane. They can ask, till now they are asked only butane and pentane. So, study well. If somebody wants to write the structural isomers of hexane, just go and write it. It will be fun. Okay. You know how to write it. Okay. Then just WhatsApp to me. I will see it. Okay. Hexane or heptane. Okay. That's it. So that is pentane. So these are called as structural isomer. So how will you define structural isomer? Compounds having same, value point is same molecular formula but different structures are called structural isomers. Got it? So these are about the structural isomers. First you draw the carbon skeleton and then you satisfy with the hydrogen. Then you get the structure, then you write the condensed formula, you will have that compound. Then make sure it is C5H12. Okay. Now we have completed the chain and the branches. Okay. Now coming to the ring structure. You know carbon can form a ring structure. For example, if I draw a skeleton like C, 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 C and C. This is a carbon skeleton and you know this is a closed, that means a ring structure. If I write like this is a carbon skeleton of a ring structure. Correct. And these are bonds, carbon-carbon, single bond, single bond, single bond, single bond, single bond. Now how many carbon atoms are there? C6. Now what you have to do is you have to satisfy the other valency by hydrogen. Now let us take this first carbon atom. How many bonds are there? Valency 1 and 2. Now how more to go? 4 valency. So 2 and again 2 are needed. So I will write 1 hydrogen here and 1 hydrogen here. Listen. Here again 1, 2, second carbon atom, 1 hydrogen here, 1 hydrogen here. So 1, 2, 3, 4. Correct. Now the third carbon atom, 1, 2, 3, 4. See, I am satisfying the valency of carbon with hydrogen. Now again the fourth carbon atom, hydrogen, hydrogen. So 1, 2, 3, 4. Hydrogen is 1, you know. Now this fifth carbon atom, again 1, 2, 3, 4 valency. And the sixth carbon atom, again hydrogen, hydrogen, the 4 valency are satisfied. So this is the structural formula of a ring compound. Okay. Now what is the molecular formula? Molecular formula is C6. Okay. How many hydrogen? Starting from first carbon atom, 2, 4, 6, 8, 10, 12. So it is C6H12. C6H12. And its name is, since it is a ring structure, you have to add cyclo. Okay, cyclo. And 6 carbon atom. And there is no double bond here. Isn't it? Saturated. You can write cyclohexane. See? Cyclohexane. Okay. So, this is called as cyclohexane. So, this is an example for a ring structure and also example of a saturated ring structure. Got it? Saturated ring structure. Okay. Now, one more example you have to study. I think you have already studied. I told you that it is an unsaturated ring structure. In board exam questions can be asked. Is it clear for you this one? Okay. So, one more example, that is an unsaturated ring structure, which is called as, you already know, it's a very important compound in organic chemistry, which is called as benzene. So many times in board exams they are asked to write the structure and formula for benzene, chemical formula. What is the formula? C6H12. Isn't it? We have now drawn C6H, this is cyclohexane, C6H6. We have drawn C6H12, that is cyclohexane. So how will you draw benzene? It is C6. So the skeleton will be the same as the other one. That is 6 carbon atoms. See? 6 carbon atoms. Okay. Like why you want to draw like this means this is this form is an adapted form. Okay. In chemistry you draw the 6 as a hexagon. That's why. Okay. So benzene is a hexagonal structure. Now see 6 hydrogen atom. Listen, 6 hydrogen atom, if I put 1 hydrogen atom in all the carbon atom, see, then if I put the valency, see if it is 1, valency of this carbon atom is 1, 2 and 3. But you have to satisfy with the one more valency. There is a fourth valency. So where you will put, you can't put here. Why? Because hydrogen is having only one valency. So you can't put double bond between this carbon and hydrogen. So you have to put either here or you can put here. So I will put here. Correct. So for this carbon atom 1, 2, 3 and 4. Correct. This is satisfied. So what about this carbon atom 2? 1, 2, 3, 4. Okay. No need to add. Now this third carbon atom 1, 2, 3. Now if I put a double bond, is it okay? 1, 2, 3, 4. Right. Okay. Now this fourth carbon atom 1, 2, 3, 4. Correct. Now the fifth carbon atom 1, 2, 3. If I put a double bond here, is it okay? 1, 2, 3, 4. Correct. Now in this carbon atom 1, 2, 3, 4. So we can say that the structure of benzene is what? CH, 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 CH and alternate single and a double bond. Alternate means if it is one single bond, then the second double bond, then single bond, then double bond, then single bond, then double bond. Or if somebody says this is double bond, you can have it. But the other must be a single bond. Then double bond, then single bond, then double bond, then single bond. So this is the structure of benzene. Or simply you can say the skeletal structure as like this, which represents, here it is a carbon, 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 carbon and hydrogen. See, this is the structure of benzene. So you got it? So just study the structure and molecular formula of benzene. This is an unsaturated. It's very important because why I said unsaturated? It contains a double bond. If it was only single bond, you can say it is a saturated. But since it contains a double bond, you can say it is an unsaturated cyclic compound. Okay. If you ask me why you haven't said, earlier you said if it is a ring, you have to name it as cyclo. But benzene is an exceptional case. Okay. Benzene is an organic compound which we say as benzene. Okay. So that is all about the chains, branches and the rings. Okay. So what I want to do is just go through the structures. Okay. Now hope it is clear. You understood. Okay. No problem. Okay. So any problem, just give me a call. I will get you there. Whatever difficulty is there, just give me a call. I will get back to you. Okay. So please, for the homework, write the structures. Write the structures of methane. So C1 to C10. That is methane, ethane, propane, butane, etc. till C10. So structures means what we have done till butane, right? Or pentane. You have to write once more from methane, ethane, propane, butane, then pentane, hexane, heptane, octane, nonane and decane. So you write the structural formula as well as the condensed formula. So both structural formula and the condensed formula. So that's the homework. Okay. So just read the textbook. Any doubt, just give me a call. Till then, thank you.